my name is Kristen Jameson, and I'm going to be talking to you a little bit about the benefits of composting. Compost is an essential tool for sustainable and organic farmers because it really promotes healthy chemical, physical, and biological processes in the soil. Benefits of compost include retaining soil moisture, reducing water runoff, improving soil tilth, recycling soil nutrients, hosting beneficial microbes, reducing the use of fertilizers, balancing soil pH, and diverting waste from landfills. Methane greenhouse gas produced from landfills contributes significantly to climate change. By diverting organic waste from landfills to be composted, soil nutrients like nitrogen, carbon, potassium, and phosphorus are returned to the soil. Compost also hosts beneficial microbes like nitrogen-fixing bacteria and mycorrhizal fungi that can increase nutrient content in soils. By promoting biological soil processes that regulate soil, land managers can reduce dependence on fertilizer inputs and save money. By increasing the soil organic matter through additions of compost, one can increase the water holding capacity of the soil, which can reduce losses of water and nutrients to heavy rains and leaching. Also, by increasing the soil water holding capacity and reducing this nutrient runoff, less fertilizer application will be needed. In addition to retaining more nutrients in the soil, by adding compost, one can actually generate more nutrients because compost hosts beneficial microorganisms like mycorrhizae and nitrogen-fixing bacteria. Other benefits of additions of compost include increased tilth or workability of the soil because the additions of compost can really lower the bulk density of your soil. In traditional compost systems, the pile needs to be turned every 7 to 10 days. For example, in this turned windrow system, the piles are continuously turned and moved down the line until at the very end you'll have finished compost. If piles are not turned, they can approach an anaerobic state, which can give off odors like ammonia and also have lower rates of decomposition. Having forced aeration also helps to increase the temperature of the pile, which is necessary to kill off pathogens. And this usually requires a temperature between 135 degrees Fahrenheit and 160 degrees Fahrenheit. Behind me is an aerated static pile composting system. One of the benefits of this type of system is that it has a lower labor requirement because the piles don't need to be turned. Instead, to ensure an adequate supply of oxygen, the bin is lined with a PVC pipe that is connected to a manifold to control airflow. This PVC pipe has holes drilled into the underside of it to prevent clogging. This 4x4x4 pile is then constructed by first layering a bed of sticks to really further prevent any clogging. Next, you're going to want to add some mulch to the pile, and then you're going to add your food waste. As a general rule of thumb, compost should be mixed at a ratio of 3 parts brown woody carbon-based materials to 2 parts green nitrogenous material by volume. To accurately calibrate the proportions of inputs to achieve the desired carbon to nitrogen ratio, you should evaluate the carbon and nitrogen content of the inputs. For example, the bulk density of the wet material, the percent moisture, the percent nitrogen, the carbon to nitrogen ratio, and the percent lignin all influence the mixing rate. For this compost pile, we are aiming for an initial carbon to nitrogen ratio of around 25 or 30 to 1. Here, we use the C/N calculator provided by Klickitat County, Washington for food waste and softwood chips. So to do this, we add about 1 gallon of food waste for every 3.7 gallons of mulch. We continue layering this lasagna style with about 6 inches of mulch followed by 6 inches of food waste and continued all throughout the pile until you reach the top, at which point you add a 6 to 10 inch layer of mulch to act as a biofilter. This will keep any vermin, roosters, mongoose out of the pile because it will insulate the pile and make the pile too hot for any vermin to get in and disturb your pile. Additionally, it can absorb any odors that may come off. For the first month, this pile will receive 100% of the airflow. 30 days after that, we can begin building our second pile. In stage 2, The first pile is reduced to 10% oxygen by adjusting the manifold in the back. At that point, the second pile will get 90% of the airflow, and they will stay at this point for 30 days. At the end of 30 days, this pile should be ready to start curing and will receive no more airflow. This pile 2, will get 10% of the airflow. And then we'll begin to build pile 3, which will get 90% of the airflow. And this cycle continues. So it takes about 3 months to compost 100 gallons of food waste in this system with very little labor requirements. This diagram helps to illustrate the process the three-stage system goes throughout its life cycle, where during the first month that the pile is built, it receives 90 to 100% of the airflow. In the second month that the pile is built, it receives 10% of the airflow. And during the third month in the curing stage, there is no added airflow into the pile. Thanks for taking the time to learn about aerated static pile composting. If you'd like to learn more about the project happening at UH, you can follow our activity on Facebook at www.facebook.com/ManoaCompost. Alright, so soil, oh god, this is so embarrassing, I hate this. Density of the soil. I feel like this is going to take me a long time. Fertilizers. He's in compost. So hard. Okay. Oh, that was awkward. Ammonia and other chemicals that smell poor. I don't talk like this when there's not a camera. Okay. The bacteria are able to convert the carbon into other carbon. I hate this so much. Cut. Static pile. The weed whacker.
Yeah.
Blah 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 blah. Bins don't need to be turned away. This is some mulch that's produced locally on our school campus, and it really helps to add labile carbon to your system. Lasagna style. Lasagna style. Lasagna style.